welcome my dear students. So today we will learn about the basics of the chapter motion in a straight line. So if you are a class 11 student, then do watch this video till the end, as I will cover almost all the important concepts here. To start with, we are talking about the term mechanics. What exactly is mechanics? So mechanics simply refers to the study of motion. Whenever you want to study anything about motion, we would say that we are studying about mechanics, or we are studying motion. That means we are studying mechanics. Now this mechanics is actually divided into two parts. We divide mechanics into two parts. We have something known as kinematics and we have something known as dynamics. Now to start with, in today's topic, we would mainly be discussing about kinematics. Kinematics is basically the study of motion without going into the cause of it. So it is simply the study of motion without going into the cause of it. On the other hand, we talk about dynamics. In dynamics, we study the cause of motion. How exactly is the motion working? Why is it working like that? So here we study the cause of motion. For example, what force are you applying? How much force are you applying is what we study under dynamics. Now, whenever it comes to mechanics or whenever we are talking about kinematics, we are mainly focusing on the motion. Now, to focus on the motion, we would be talking about a few basic terms that are related to motion. So, to start with, we are talking about the frame of reference. What is the frame of reference? Frame of reference is a place from where you observe the motion. So, for example, let's say that there is Earth over here. Okay, this is Earth. And there are two people standing over here. Now, if they both look at one another, they're just standing still, okay? Now, if they look at one another, then they both appear to be at rest, right? They will say that we both are not moving. So this is my frame of reference. What is my frame of reference? It is the Earth, because I am observing the other person from the Earth. On the other hand, suppose, let's say that there is a person standing on moon, right? And he observes the motion from moon. So his frame of reference is the moon because he is observing from moon. So from wherever you observe, that is your frame of reference. A place from where we observe the motion is the frame of reference. If you observe from Earth, then Earth is your frame of reference. If you observe from a car, then your car is the frame of reference. If you observe from the moon, then moon is your frame of reference. Now, when it comes to frame of reference, we also talk about two very competitive terms. They are rest and motion. Now, for example, over here, when this A person is looking at B person, he is saying that B is at rest. When A looks at B, it appears as if B is at rest. But when this person C, who is standing on the moon and observing B, for him B would be in motion because Earth is in motion. So when you observe the same thing, the same object from two different reference frames, then the motion can appear to be different. Therefore, whenever we talk about rest, rest means that there is no change of the position with respect to the surroundings. On the other hand, motion means that there is a change in the position with respect to surroundings. So if there is a change, then it is in motion. If it is at rest, then it is not moving. But motion and rest both are relative terms, because when you observe from different reference frames, then the same motion can appear to be different. Now let's come on to the terms distance and displacement. What exactly is distance? What exactly is displacement is something that we will try and understand here. So firstly, let us talk about distance. Now, whenever we are talking about distance, distance means the total length of the path that you travel. Whatever is the total length of the path traveled is what we call as distance. So it is the total length of the path traveled. It is also the actual length of the path that you follow. Also, distance is a scalar quantity. There is only magnitude associated with it and no direction. Because it is a scalar quantity, therefore it would always be positive. It can never be negative. Also, distance never decreases with time. It never is the word here, it never decreases with time. On the other hand, we have displacement. Now, displacement is always the shortest length between the initial and the final positions. It is always the shortest length between the initial and the final position. Now, whether you follow this path or you may not follow this path, but it is still going to be the shortest length. Irrespective of the fact that whether you follow it or not, it is always the shortest path between the initial and the final positions. And the shortest length between any 2 points generally is the straight line distance between them. So you may not have a road along that straight line, you may not have a path only you along there, but still it will always be the straight line path between 2 points is going to be your displacement. Now, displacement is a vector quantity. That means that there is a direction and a magnitude associated with it. Also, because it is a vector, therefore it can be positive or negative, and it may decrease with time. It may decrease with time. Let us pick up some examples to understand what exactly do I mean by both of these. So for example, let's say over here I tell you that there is a person who traveled 2 kilometers. He has traveled a path of 2 kilometers. Then that simply means that this is distance. Why is this distance? Because I only know that he walked or he traveled 2 kilometers irrespective of where he went. He may have gone to the north direction, he may have gone forward, backwards, somewhere. I do not know that. All I know is that he has traveled a distance of 2 kilometers. Therefore, it's a scalar quantity, it is just distance. On the other hand, if I tell you that there is this person who traveled 2 kilometers towards north, then this can be the displacement, because over here I know the direction as well. Because I know the direction, therefore this may refer to the displacement. Why? Because I know how far he has traveled, but I also know the direction in which he has traveled. Let us take another situation here and try and understand. Let's say that there is this person A, okay, and this is A's home, and her school is at some distance. Let's just say that the length between his home and school is 5 kilometers. Okay, so now during the morning or during morning hours, A goes to school from his home. So he goes to school in the morning, and in the afternoon he comes back home. Now during this path, the total distance that he covered is going to be 5 kilometers while he went to school, 5 kilometers when he returned from school. So the total distance here is 5 plus 5, that gives you a total of 10 kilometers. On the other hand, the same person, if I talk about his displacement is going to be 0. Why is the displacement 0? The displacement is 0 because he went 5 kilometers, he came back 5 kilometers. That means the initial and the final position both are A. He started from here, right? So that means this is the initial point. He went to school, he came back. Because he came back, therefore, this is also the final point. Since the initial point and the final point both are same, therefore his displacement is 0. You can also think of it like this, that if going towards right was taken as a positive 5 kilometers and coming in the reverse direction was taken as negative 5 kilometers, then plus 5 and minus 5 will give you a displacement of 0. So therefore his displacement is 0 kilometers. I hope you understand. Further, I would like to add in over here. So let's say that if you have distance and displacement for any sort of motion, okay, your distance may be equal to your displacement or it can be greater than your displacement. Your displacement can never be greater than the distance. See, if you follow the shortest possible path, like if the shortest possible path is also the actual path, then your distance and displacement would be equal. But in case you are following some other path other than the shortest path, then your distance would always be greater than your displacement. So distance and displacement may be equal or your distance may be greater than the displacement, but your distance can never be less than your displacement. Do keep this in mind. Now, let us talk about the next term, which is speed. So, speed basically tells us how fast an object is moving. How fast are you moving, or how much is the length of the path that you are traveling in a particular time. So, if I talk about the average speed is the total change of distance in a given time, or you can say the total length of the path traveled in a given time. If you want to calculate the average speed, then average speed would be given by the total distance by the total time. Now, since we measure the distance in meters, time in seconds, therefore your average speed could be measured in meter per second. In case you measure the total distance in kilometers and the time in hours, then your average speed would be measured in kilometer per hour. Also, speed is a scalar quantity, so again there is no direction associated with it. Now this is for the average speed, okay? But sometimes we would want to calculate the instantaneous speed. If you want to calculate the instantaneous speed, then for that you will have to take the derivative of position with respect to time. You will have to differentiate position with respect to time. Another way to write the same thing is the integration of v dt by dt. In case you do not know about differentiation and integration, then we have videos coming up on differentiation and integration as well. So stay tuned, subscribe to the channel and keep watching in here. Further, instantaneous speed is dx by dt. So you'll have to differentiate the position with respect to time. The units remain the same and also this is just a scalar quantity. See, understanding speed is very easy. Whenever we are differentiating the position with respect to time, all that we are trying to measure is the change in the distance with respect to time. And that's exactly what is your speed. Okay, now we shall try to answer a question. It's a NEET PYQ. A vehicle travels half the distance with speed v and the remaining distance with speed 2v. Its average speed is. So the question is pretty easy actually, and these type of questions were very, very much expected in the NEET exam in the past years. These days they are not very common, but since it's a 2023 paper, we may, get a similar question back again now. So over here, since they are saying half the distance and the remaining distance, so let's just assume that the total distance here is 2x. So half of this distance will be basically equal to none other than x, because half of 2x is going to be x. And then I know that this half was traveled with a speed of v, right? And then the other half. because if half has been gone, then the remaining part is also going to be half. So the other half or the other distance is going to be x as well. And the speed with which this was covered is 2v. Now I have the average speed formula and I would directly use that to calculate the speed. So if I want to calculate the average speed, then average speed is simply going to be the total distance by the total time. Now we already assumed the total distance to be 2x, and to calculate the time in each situation. See, the time for the first half, the t1, it would be equal to the total distance by the speed, because speed is equal to distance upon time, so time would be distance by speed. So this is going to be x by v. On the other hand, the time t2 over here would be x by 2v. So the total time that I have over here is going to be t1 plus t2, and if I substitute these, I will have 2x by x by v plus x by 2v. On simplifying this, I can further write down I have 2x, and this would become 2x plus x by 2v. This further simplifies to 2x by 3x times 2v. So this x and x get cancelled and your answer comes out to be 4v by 3. This is the average speed in this situation. It's a very easy question. Only thing is that you have to keep the basics in mind, that if you're calculating the average speed, you take the total distance by total time. You do not calculate the average speed by taking the average of v and 2v. You simply use the formula and substitute as required. The next term that we come across is velocity. So velocity is the rate of change of displacement with respect to time. Just like the speed, if you want to calculate the average velocity, then average velocity would simply be equal to the total displacement by total time. How do you find the displacement? To find the displacement, you have to take the length between the initial and the final positions. So x2 and x1 are the initial and the final positions divided by the time, which is t2 minus t1. Now because velocity is dependent on displacement, therefore it is a vector quantity. That means the direction also plays a role here. Just like speed, if I want to calculate the instantaneous velocity, then it can be calculated easily by simply differentiating the position with respect to time. Instantaneous velocity simply means the velocity at this particular instant of time. Now we have some very important points related to speed and velocity here. Try and understand each of them. I'll explain them with examples. See, if the velocity is constant, velocity constant means my magnitude and direction both are constant, right? If both of these are constant, then by default speed is constant, right? Because speed only refers to the magnitude part. And when I say velocity constant, that tells me that the magnitude and direction both are constant. So that also implies that the speed is constant as well. Let us look at the next situation. If we say that the speed is constant, now if the speed is constant, that means only the magnitude is constant. That does not tell us anything about the direction. The direction may be changing. Therefore, we would say that the velocity may be variable. If the direction changes, then velocity is variable. If the direction did not change, then the velocity is not variable. That is why we are saying it may be variable. On the other hand, if I tell you that the speed is variable, if the speed is variable, that means your magnitude is changing. If magnitude is changing, then velocity by default is variable, right? Because if magnitude is not constant, then velocity cannot be constant. And lastly, if I tell you that the velocity is variable, if the velocity is variable, that means again my magnitude or direction or both of them are changing. If they are changing, then speed may be variable, because if the velocity is variable, it could be due to magnitude, it could be due to direction, or it could be both of them. If it is due to magnitude, then speed would be variable. If it is due to direction, then speed will not be variable. That is why we are saying that the speed may be variable. Understood? I hope that's clear. Now we come on to the last term of mechanics over here, or basically kinematics, which is acceleration. Acceleration is the rate of change of velocity with respect to time. If you want to calculate the average acceleration, all that you have to do is you have to do the change of velocity or the change in velocity and then divided by time. So change in velocity by time. Now when you are doing change in velocity, that means you have to do the final velocity minus the initial velocity and then divided by the time that you took to change the velocity. Now because velocity is measured in meter per second and time is measured in seconds, therefore the unit for acceleration would be meter per second square. So many a times children get confused, whether it's acceleration, whether it's velocity. Always look at the units. It will sort half of your doubts. So this is a meter per second square here. Okay, now acceleration is also a vector quantity because it is dependent on velocity. Therefore it can be positive, negative, or zero as well. Negative acceleration is what we call as retardation. Negative acceleration is called as retardation, or it is also called deceleration. If you want to calculate the instantaneous acceleration, then that would be equal to the derivative of velocity with respect to time. dv by dt would give you the instantaneous acceleration. Now we further have acceleration of two types. There are two types of acceleration that I would like to talk about today. We have something known as the tangential acceleration. So let's talk about the tangential acceleration first. As for the tangential acceleration, it is the acceleration in which only the magnitude of velocity changes. It acts along the velocity, so the tangential acceleration is given by dv by dt, or double derivative of position with respect to time. On the other hand, I have centripetal acceleration, which only changes the direction of velocity and it always acts perpendicular to velocity. Centripetal acceleration would be equal to v square by r. And now we come on to another NEET PYQ, which says that there is a bus traveling the first one-third distance at a speed of 10 kilometers per hour, the next one-third at 20 kilometers per hour, and the last one-third at 60 kilometers per hour. And you have to find in the average speed. So here again we will follow the same procedure. So we let the total distance be 3x. So let the total distance be 3x. Now when I say one third of the distance, so one third of 3x would be 1/3 of 3x would just be x, right? So for the first 1/3, for the first part, the distance traveled is x and the speed with which it is traveling this distance is going to be 10 kilometers per hour as it is given to us. And now if I need the time for this particular part, then that would be x by 10. So t1 is x by 10. Similarly, for the second part, the distance would be x and the speed would be 20, so the time would be x by 20. For the third part, the distance would be x, speed would be 60 and the t3 would be x by 60. If you want to calculate the average speed, we have to do total distance by the total time. Always remember the formula. If you remember the formula, then all that you have to do is just substitute. So total distance in this situation is 3x and the total time would be t1 plus t2 plus t3. So if I substitute the values of t1, t2 and t3, I would have x by 10 plus x by 20 plus x by 60. Now when I simplify this, I would have 3x by. This becomes 6x plus 3x plus x by 60. So this further gives me, I have 3x by 10x into 60. The 0 gets cancelled, x also gets cancelled, and you have 6 into 3. That gives you the answer of 18 kilometers per hour, which is my final answer. So I hope you learned something in today's video and you were able to grasp all the concepts that I taught you today. Thank you for watching and subscribe to my channel for more learning.